Hello, my name is Selena Salon, and I will be going over a question from one of the beginning mechanical engineering civil major classes. It is 2410 statics with Dr. Naveen. The problem I'll be going over is problem 685. I'd like to note that in these classes, as you get more into the engineering classes, um, they're going to become more intensive and really difficult to understand. That's where usually students get caught up. They're not 100% sure with what the question is asking, or just pretty much the basic things, given things. Since there's so much going on, they don't fully take in everything. So that's what I like to do. And this is a problem from a exam or a quiz or homework. I'm honestly not sure. I just pulled it out and decided that this would be a good question to go over because a lot of people I remember at the time got really caught up with it in my class. Okay, so let's start out the problem. It says a shelf below shows a weight of 200 pounds, and I like to mark everything up. It kind of looks like a mess later on, but it's good because as this problem is going to get really difficult, it's good to have everything written down because you can look back on it. You only have so much time to complete these problems if it's on an exam or a quiz. Um, and yeah, pretty much I'm going to start by obviously analyzing, and then I'm going to write down all of the givens. So the shelf shown below weighs 200 pounds and is supported by a horizontal position by a single hinge and a cable. Assume that the shelf is aligned so that it exerts no moment at reaction in hinge A. This is really important, and I'm going to just write it out. MA is equal to 0. Um, and this is just the moment in the counterclockwise direction is 0. This is important because it's going to help us solve the problem. And it's really important that we obviously know all of this. So determine all the reaction components at hinge A. So this is what we're going to have to find, and the tension in the cable. Show all values on a free body diagram. It's important to read the whole question because sometimes we'll get so caught up later on in just finding the reaction components at hinge A and tension and cable, but we will forget to show the values in a free body diagram, which is probably the easiest part because you already found all the values. You just have to draw it all out for it to make sense. Now what I'm going to do is you can kind of see the eraser marks because I couldn't find this as a PDF online, so I just had to take a picture of my old one. I have it to reference here. So you can see that I started here by adding 13 plus 13. Just to make this easier, say for example, when we're finding this point B, because I'm going to find all the coordinates and then solve the problem. Um, for this point B, to not get confused and think, because there's so many numbers here and it's so easy to get confused, to make this point B something wrong. So I'm just going to put this 26 here, and then we can also see here this C, it's not proportionate, it's not, the value here is not from C to Z. And that's going to be more difficult to find when we're finding the coordinate system. Oops. Finding the coordinates for C. So here we have 28 and here we have 12. So I'm just going to do 28 minus 12 is 14. So we're going to do that there. And it's also really important to note this point G. I added it in, but I'm just going to go over it. This point G here, because we're given that the shelf shown below weighs 200 pounds. Oops, I kind of went over it. The shelf shown below weighs 200 pounds, and it's important in statics, and you probably understand that the center of gravity is really important in these questions because we're going to add all the forces to find FA, so the components at hinge A, and tension in the cable. So then what we are going to do here is this point G. So we have to find this point G as well, and it's just going to be in the center because we're given this 200 pounds. So now what we're going to do is we're going to find all the coordinates. I have this drawn out on the side just so I don't have to keep going back and forth. But if you have this question in front of you too. Sorry, my iPad froze. Okay, so point A, we're going to write down all the coordinates. So coordinates we have point A, point B, G, and C. So let's find all of those. So we have A, and A is at 0, 13, 0. We have B, which is right here. So it's not at the edge. So we're gonna have to find this. So at X right here is 28 minus 2. Like I said, it's not at that edge. And then um, right here for Y, it's going to be 26 minus 2 because it's also not at the edge. So 26 minus 2. And then since A or B are neither in the Z direction, it's going to be 0. And now C, we have it at 14 because we found that 14 earlier. 14. There isn't anything in the Y direction, so that's going to be 0. And then we have Z, which is 20. And then we also have to find G, which is just going to be in the center. So it's going to be everything divided by 2. So it's going to be 28 divided by 2, 26 divided by 2, and then 0, which is also equal to 14, 13, and 0. And this here is 26, 24, 0. Okay. So now we have to focus on forces. So now we have all the forces equal to 0. So we have FA, that's what we're trying to find, plus FBC, we're also trying to find this, and we have minus, I accidentally put plus, but it's minus FG because it's gravity and gravity goes down. This we are given. This we're trying to find, and FA we are also trying to find. So we will find FBC first and then find FA just because it'll be more simple this way and it'll be quicker to find. Okay, before we get into the forces, it's really, really important to also initialize everything, just like how I said before, but I think it's better to go in this order, explain the forces, why we're doing the forces, and then go into the distances. So we're going to find the distance of A, of G relative to A, and then of B relative to A, and then of C relative to B. So we are going to do this, RAG equal to RAB equal to RBC equal to. And then we're going to find it. So we're going to do the coordinates of G first because it's G to A. So we're going to write down all the coordinates of G, which is 14, 13, 0, minus the coordinates of A. So 0, 13, 0, we're going to get 14, 0, and 0. And then do the same thing for RAB and then RBC. So 26, 24, 0, and then 0, 13, 0. Get 26, 11, and 0. Now, RBC is going to be coordinates of C, so 14, 0, 20, and then coordinates of B, 26, 24, 0, and then get negative 12, negative 24, 20. Okay, now, to find F of BC, this is a vector. So we have to find the actual value of FBC so we have this. This is equal to FBC, the unit vector of FBC. So we have RFBC, and this is the unit vector, RBC squared. So we're going to take these values, put them on top, and then square it. So we have FBC negative 12, negative 24, and 20. and then divided by all of these squared. So negative 12 squared plus 24 squared plus 20 squared. And I'd like to just go in depth with this because when it gets to these decimal points and whatnot, it gets really confusing and it's really easy to get lost, or you get one small thing wrong and then you're completely off. So I'm just going to go through all the decimals and through all of the steps of this problem just so you can make sure that you're not stuck at all. So we have this, which is going to be FBC, negative 12, negative 24, and 20, divided by 144, 144 plus 576 plus 400. And then this is going to equal to FBC. And you have to keep this FBC. Every single time you write this out, you have to write the FBC or else you're going to forget to put it. And because this is not equal to this. This is a vector and this is a scalar. So we have to find the scalar in order to fully find the vector form. Okay, so now we have FBC, negative 24, negative 12, negative 24, 20. And then once you add all of these, I just did the calculations in advance so we didn't have to spend too much time on them because we're not going to be focused on that. We get this number, which is also equal to FBC, negative 12, negative 24, 20, divided by 33.466. Okay, and just so we don't get confused here, because you can get lost really quickly, like what I said before, I'm going to find the values of these, each of them separately. So since this negative 12 is in the x, it's going to be in the y direction, in the I direction. This negative 24 is in the y direction, therefore it's going to be in the j direction, because I, j, k, x, y, z. And then this 20 is going to be in the k direction. So let's do I first. So we have negative 12. And here I'm just finding them separately, but I will include the FBC back again. So negative 12 divided by 33.466. And I got that value to be negative 0.35857. Something engineering professors aren't too crazy about is rounding really quickly or rounding too early. So what I like to do is I like to write out the whole number, even though it might get confusing and you might mess up a decimal place here and there. But if it counts, it counts. You have to do it. And then later on, I round. So we have the I, and then the J is negative 24 divided by 33.466, and you get negative 0.71714. And then the K, we have 20 divided by 33.466 is equal to 0.59761. And like I said, I already calculated all of these. And then we can plug this back into here to get the vector of FBC to then find what FBC is. And I will show you how to do that in a bit. So we have FBC, and you can write this out in two ways. I will show you both of the ways. So FBC equal to negative 0.35857, 57, negative 0.71714, 0.59761, or you can write it out like this. So for this is just the convenience and being able to see it. I always write them out both ways and whichever way works best later on, because sometimes one way will work better than the other, but it's pretty basic. So now we have to find this value of FBC, and how we can do this is, you know how earlier I said it's really important that they said no moment exerts reaction on hinge A? We're going to find the moment at A. So let's do moment of A equal to 0 and counterclockwise direction positive. So we have two things. We have this gravity force and we have FBC. They're both exerting action on A. So we're going to do RAG cross this FG, and then RAB cross this FBC, and we will be able to get FBC. So let's write that out. RAG times plus equal to 0. I'm going to do this in parts so that way we don't get lost. So the first part will be about this, and the second part will be about this, because there are so many numbers and decimals and all that. So we have part 1. So this is going to be the cross product. We've done this a lot, so I'm not going to do the exact ones, but I will explain it. I just won't write it out. So we have I, J, K. We're going to put out the values of RAG, and then FG was given because we had 200 pounds of the center of gravity. So since it's only going down and not in the X or Y direction, it's just going to be 0, 0, negative 200 because we were given 200 pounds and it's going down in the K direction. So we have RAG as 14, 0, 0. And then we have FG as 0, 0, negative 200. So usually what we'll do is we'll do like I, and then cross this out, do this. But as you can see, this is 0, and it's 0 times negative 200 is 0, and then 0 times 0 is 0. So it's just going to be I times 0. And then again, we have this J. But in this J, it's going to be minus J. And we have 14 times negative 200. So it's going to be 14 negative 200. And then we have, like, obviously 0 times 0 is going to be 0. And then we have the K, which we're going to cross this out. Sorry, it's getting really messy. We have this K, and 14 times 0 is 0, and 0 times 0 is 0. So, and then we have R A G times FG is going to be, I have that as 2, 0, J. Now, the second part is this RAB times FBC. So we're going to find that by also doing the cross product. So part 2, we have RAB cross FBC, and this is going to be a lot more complicated because we have all those values of FBC and they're all decimals. I, J, K, but it's pretty much just plugging and chugging on your calculator. So I'm going to put the decimals all out, but I won't do the actual calculation because that's not what we're focused on here. But yeah, let's get this started. So we have RAB, which is 26, 11, 0. Now we have negative 0.35857 FBC. I'm just putting it down, but it's multiplied by it. Negative 0.71714 FBC. Same thing here. 0.59761 FBC. And the same thing with this cross product. So I is going to be 11 times 0.59761 FBC And then we have the j component, which is just going to be, minus j. Minus j 26 times 0.59761 FBC plus K, which is, I have the value in front of me, K 26 times negative 0.71714 FBC minus 11 times 0.35857 FBC. Okay, so we're going to add these terms and whatnot, and now we're going to go back to the main equation and plug in the values. So we have here, when you multiply it all out, we end up getting 6.5738 FBC I plus 2800, which this was from that first part. So everything is from part 2 pretty much. Here we're just putting them all in the I or J, all of the I, J, or K components, and that's how we kind of do these kinds of problems, because we're going to set them equal to 0 and then get FBC that way. So we have 2800 minus 15.538 FBC J minus 14.701 FBC K equal to 0. Now, we have this and we have this, but it's not going to make any sense because FBC is going to be 0 and we're looking for it. So we're going to take this part and set it equal to 0. So 2800 minus 15.538 FBC is equal to 0, and then we end up getting FBC is equal to 180.2 pounds. So that's one thing that we were looking for. And it could either be in compression or tension, but if your value comes out as positive, it's going to be tension. And if it's going to be negative, it's going to come out as compression. Okay. We just got the hardest part done, and we have a little bit left, but they're not as difficult as that part because that part had a bunch of cross products and that gets kind of confusing. So let's plug this FBC value back in. So we have FBC, the vector, we're going to do 180.2 times 0.35857, 0.7. And now we're going to calculate that. We end up getting this. And then you could write it out just like how I did before with the IJK components, but I'm just going to leave it as this for now. So now we're going to plug this. Now that we have FBC and we have FG was given, we're going to find FA now by plugging in the first equation that we found. So we have let's plug that in. And then for FA, we're going to do AX I plus AYJ plus AZK. So let's do that. Plus the values for FBC, so negative 160, 14I minus 129.23J plus 107.6. Okay. Minus the 200. Okay. Equal to 0. So since there are so many values here, it's important to add the I components with the I components, and the J components with the J components, and the K components with the K components to get AX, AY, AZ. So let's do the I's first. So we have AX minus 64.614 equal to 0. And so you're going to equal them to 0 to get these values. There's no reason really to plug them back in and really solve it by just plugging them in and setting them equal to 0 when you've already found them here. So let's just do that. So AX is going to end up equaling 64.614 pounds. The J's, we're going to do that. AY minus 129.23 equals 0. You get AY is 129.23 pounds. The K is going to be a little bit more complicated because we have two K components. So we have AZ, oops, I meant to add a plus sign there. Oops. AZ is 769 minus 200 equal to 0. So we end up getting AZ is 92.04. So therefore we found FA. So FA is going to be equal to these values: 64.614, 129.23, 92.04 pounds. So we found both of our values, but we are not done yet. The last part of the question, like how I said before, show all the values on a free body diagram. So you can't forget that because you will miss points on that problem. Okay, let's draw this out. And this is probably the simplest thing because you already have all of your values. Actually, yeah, you have all of your values and all you have to do is just draw it out. So this is the easiest part, but everyone always misses it because it's a long problem and you've already done so much. So you get exhausted, but don't forget this part. This part is really easy to get. So let's do this. Let's draw it out. And it doesn't have to be perfect. Engineering professors know that you're not an artist, or else you would be an art major. But drawing this out accurately and putting out all of the numbers will ensure your grade. And this is X. So first we have point A. These are the values we all just found. So AZ equal to 92.04 pounds. And then the Y, we have AY to 129.23. You don't have to do this part, but I also like to do it, including the coordinate. 13.0 AX. Don't forget that FG, negative 200. And since you're drawing them out, trying out the vectors, you don't have to include I, J, K, because you have the AZ, AY, AX, and then that. And then B here to C. And this value is 180.21 lb. FBC. Tension, because it's not negative. And let me just draw this out. I know it looks like a lot, but it's pretty basic because you've already found all of the values. And yeah, that is pretty much it. I hope you guys enjoyed watching this video, and I hope that it was helpful for you. I wish you good luck with all of your studies, and goodbye.